In the 1990s, video games had a problem. Dragons didn't look real enough. Explosions were blocky. Character faces looked like someone sculpted a human out of mashed potatoes and called it done. This was unacceptable. Gamers were upset. Deeply, passionately, extremely online upset. So a small company in California decided to fix it. They hired engineers. Brilliant engineers. Engineers who spent their days thinking about one thing and one thing only. How do you make a dragon look real? They worked on this for years, then decades. They got very, very good at it. Dragons looked incredible. Explosions were beautiful. Character faces no longer looked like mashed potatoes. Mission accomplished. And then, one day, 20 years later, a group of AI researchers looked at what these people had built and realized it was exactly what they needed to build artificial intelligence. The dragon people had accidentally built the engine of the AI revolution. Hey, what? What a GPU actually is, and why the answer is weirder than you'd expect. Let's talk about what these engineers actually built, because it matters, and because the explanation involves a stadium full of surgeons. A regular computer chip, a CPU, is built for sequential tasks. Do this, then this, then this. One thing at a time. Very fast, very smart. Like a single surgeon performing a complex operation. Precise, focused, one patient at a time. Very good at what it does. Also, not helpful if you need a million things done simultaneously. A GPU is completely different. A GPU doesn't have one brilliant processor. It has thousands of tiny, simple processors, all running at the same time. Not one surgeon, an entire stadium of surgeons, each one doing something almost insultingly simple. Together, unstoppable. For video games, this makes perfect sense. A screen has millions of pixels. Every frame needs every pixel recalculated, at 60 frames per second. That's not a job for one genius. That's a job for a stadium of people doing the same simple math over and over without complaint. So that's what Nvidia built. Starting in 1993, at a Denny's. 3 engineers, one very large ambition. Absolutely no idea they were accidentally building the future of intelligence. And, for the record, very cheap coffee. The Grand Slam breakfast. Foundation of modern AI. You're welcome. The moment AI researchers discovered gaming hardware and tried to act casual about it. In the mid-2000s, training a neural network was a deeply humbling experience. You'd start the training, go home, sleep 8 hours, come back, still going, go home again, order dinner, watch television, sleep again, still going. The training times for serious neural networks were measured in weeks, sometimes months. This was not a workflow. This was a commitment, a lifestyle, something you mentioned at the start of therapy and were still mentioning at the end. And then 3 researchers at Stanford, Rajat Raina, Anand Madhavan, and Andrew Ng, had an idea. What if neural networks and GPUs were secretly the same problem? Training a neural network means doing millions of tiny multiplications, simultaneously, over and over, adjusting millions of weights, all at once. That's not a sequential task. That's a parallel task. That's what GPUs were literally designed to do, except for dragons. They published a paper in 2009. The finding, a task that took several weeks on a regular processor, took 1 day on a GPU. 1 day versus several weeks. The AI researchers stared at this result, then looked at the gaming industry. The gaming industry was busy arguing about frame rates. It had absolutely no idea it was about to become the backbone of artificial intelligence. CUDA. The key nobody knew was the key, until it had already unlocked everything. In November 2006, Nvidia released something called CUDA, Compute Unified Device Architecture. A name so technical it sounds like it was invented by a committee that hated abbreviations, and also hated you. The idea was simple. Let people program GPUs for things that aren't graphics. General purpose computing on graphics hardware. Nvidia's intended audience for CUDA? Scientists, physicists, meteorologists, people who simulate fluids for fun on weekends. Legitimate, respectable, non-dragon related use cases. AI researchers were not on the list. In 2006, AI was still considered an eccentric field, still recovering from decades of promises it hadn't kept. Still the weird cousin at the computer science family reunion. The one who shows up, says something confident, and then disappears for 5 years. But CUDA handed AI researchers the keys to the most powerful parallel computing hardware on Earth. Hardware that was already being mass-produced, already being optimized every year, already getting cheaper, because teenagers kept buying graphics cards for games about dragons. This kid right here, accidentally funded the infrastructure of the AI revolution. He doesn't know. He's arguing about spawn points. Don't tell him. He'll want credit. 2012. The year the most important AI experiment in history happened in someone's childhood bedroom. Then came 2012. The AlexNet team had a problem. They needed to train a massive neural network on 1 million images for weeks, continuously, on very powerful hardware. The hardware they had: 2 Nvidia GTX 580 graphics cards, $500 each. The kind you bought at a computer store, the kind designed for gaming. And the location of this groundbreaking experiment? Alex Krzyzewski's bedroom at his parents' house. The most important AI experiment of the decade, in a childhood bedroom, with gaming graphics cards, at mom and dad's place. If his parents had asked him to clean his room, modern AI might have been delayed by 6 months. The results came back. AlexNet's error rate, 15.3%. Every other team in the competition, 26%. The gap was so large the judges checked the numbers twice, then a third time, then asked if someone had made a mistake.
Wait, did someone mess up the code?
There was no mistake. Deep learning had arrived, from a bedroom, on gaming hardware, funded by teenagers. Geoffrey Hinton, the supervisor, the professor, the Nobel Prize winner, later described the whole AlexNet experience in one sentence.
Ilya thought we should do it. Alex made it work, and I got the Nobel Prize.
The most consequential scientific result in the history of artificial intelligence, summarized as a setup and a punchline, by a Nobel laureate. Correct. The part where Nvidia becomes worth more than most countries, and nobody quite knows how to feel about it. After 2012, demand for Nvidia GPUs went from steady gaming market to
Please, we are begging you. We will pay anything.
AI labs bought GPUs by the thousands, then tens of thousands, then hundreds of thousands. Training a serious AI model today requires not 2 GPUs, not 200, tens of thousands, running simultaneously, in warehouses the size of airport terminals, consuming enough electricity to power a small city. Which is alarming, but also, the dragons do look incredible now. Nvidia responded by doing what Nvidia does, building more powerful chips. The Tesla series, the V100, the A100, the H100, each generation faster, each generation more expensive. The H100, Nvidia's flagship AI chip, costs around $30,000 each. Microsoft is buying them by the tens of thousands. Google is buying them by the tens of thousands. Meta is buying them by the tens of thousands. Amazon is buying them by the tens of thousands. And somewhere, a 15-year-old is buying a gaming GPU for $40 less than it should cost, because the factories are too busy making H100s. He doesn't know he's part of the cycle. He never knew. In 2023, Nvidia crossed $1 trillion in market cap, then $2 trillion, then $3 trillion. In June 2024, it became the most valuable company on Earth. By 2025, it crossed $5 trillion. In 1993, 3 engineers sat down at a Denny's in San Jose. They ordered coffee. They talked about dragons. Specifically, how to make them look more real on a computer screen. That was the whole plan. 30 years later, the hardware they built to render those dragons is running inside every major AI system on the planet. Every chatbot, every image generator, every system that recognizes your face, recommends your next show, or writes your emails. Almost certainly trained on Nvidia hardware. Jensen Huang later described what Nvidia had spent 30 years building. An engine for doing many things simultaneously at a scale the world had never seen.
This is a new way of computing. Accelerated computing is the future.
The company that started making graphics cards for teenagers, now worth more than the entire GDP of Japan. The teenagers have no idea. They're still arguing about spawn points. But somewhere in San Francisco, a man named Sam Altman was about to show the world what you could actually do with all of this. Oh, this is going to be a whole other thing.